All right, the last two functions that we have to deal with are the cosecant and the secant. These are actually not that bad because what we're going to do is we're just going to use our sine and our cosine graphs to make our secant and cosecant graphs. Okay, because cosecant is just 1 over the sine. So that means whatever my y value is from the sine function, I can just reciprocate it to get my cosecant value. So what that's going to look like, I'm going to graph just some points on my sine function. So sine of 0 is 0, sine of pi over 2 is 1, sine of pi is 0, sine of negative pi over 2 is negative 1, sine of negative pi is 0. Okay, so these would be points that are on my sine function. To get cosecant values, I'm going to reciprocate these. So first let's look at 0. Let's say the sine of 0 equals 0. If I reciprocate both sides, okay, then I'm going to be taking 0 over 1 and flipping it to get 1 over 0, which is undefined. So this is actually going to turn into an asymptote for my cosecant function. And anywhere that I have a 0 is actually going to be an asymptote. Okay? Now, if my sine value is 1, if I reciprocate that, I still get 1 over 1. So this is going to be the same point, and this will be the same point, because negative 1 reciprocated is still negative 1. Now, the points in between here, okay, I would have something like, somewhere around here I would have like a half. Okay, because this is 1, so I would have a half. If I reciprocate a half, I have 2. Here I might have 1/10. If I reciprocate that, I get 10. Maybe I have 1 over a million. If I reciprocate that, I get a million. So what this is doing is, as I get closer and closer here, it's approaching this asymptote and heading off towards infinity. Here, everything would be the same except I'd be heading towards negative infinity. Okay, and the speed with which I do that is going to depend basically on my sine function. Now, this doesn't look like a wave, but it still has a period. Okay, the period is the same. It's still 2 pi. My amplitude really just determines how far off this base I am. Okay, so this would be my amplitude. My period would just be the distance between two intervals. Okay, because I've got a down circle, or a down U and an up U, and that's one full period. If we look at the cosine function, okay, we're going to have something very similar for this one. Okay, all these zeros turn into asymptotes, okay, for my secant function, and I'm going to make the u's again. So basically, in order to graph cosecant and secant functions, you're just going to graph either a sine or a cosine first to get the maximums and minimums and your zeros, and then convert them into asymptotes and u's. So let's look at a converted one. So this is secant, which means I'm actually going to graph the cosine with all the same transformers on it. So I'm going to factor here. So if I'm factoring out 1/3, that's the same as timesing by 3. Okay. So my amplitude is a half. My period would be 2 pi times 3, which would be 6 pi. So what I'm going to do is I'm going to put a couple extra lines in here. Okay, so if I'm actually, yeah, let's do that. So since I'm going up 1, I want to put my base line in here just as a reference. And then I'm shifted back, or to the right, 3 pi. Okay, so if I go right 3 pi, but I have a period of 6 pi, that means, so let's just count by pi's then, okay? This is pi, 2 pi, 3 pi. Okay, this would be my starting point. And that'd be an amplitude up from that. An amplitude is a half, so I'm going to go up a half. Okay, now my full period is 6 pi, so I can go either way. I'm going to go backwards just because I have more space going this way. So I'm going to go back 6 pi. There's 3, 4, 5, 6, and that's when I'll be back at my max again. Okay, so halfway in between here I'll be at my min, which is half below my baseline. And halfway in between these is where I'll be at 0. So halfway between 0 and 3 pi is 3 pi over 2, which would be in here. In here. Okay, this is 3 pi over 2. Negative 3 pi over 2. So now that's what my cosine function would look like. But I got to remember I'm actually doing secant. So this, where it would be like my quote-unquote 0, is actually going to become my asymptote. This is going to be an upward U. Let's put in my other asymptote, which would be, let's see, 1. There you go, another. Let's see, every 3 pi. So 3 pi away from negative would be 6, negative 9 pi. So this would be, or negative 9 halves. So this is 6 halves, 7, 8 halves, 9 halves. Here I need to go another here. And here's my downward U. Okay, so there's my secant function. I really only need 2, I need an up U and a down U, but since I had enough to do 3 in there, I just put 3. So that's secant and cosecant. You just graph the reciprocal function first and use that as a baseline to graph the secant or cosecant.